depend on the formula. You forget the formula, you are game over. Okay. I did not understand this in 2P. Now I'm starting to understand. Milika, it's not you did not understand, okay? You had some background in 2P, okay? Now you see it better, Milika, okay? It's not you did not understand. You knew about it, okay? It's not you don't understand, okay? You do, okay? That's why this is a quick revision. In the quick revision, you can recap things much quicker. That's why I need to go to this stage, okay? Because later on, when we do 3D, you have to nail this shit right, man. If you can't, okay, we're in trouble, okay? Now, let's look at MY now, okay? Let's look at MY. So for MY, is in this, I just push MY over this side so not make it too crowded, okay? So this is our MY. Okay, this is our MY. So if you look at how the moment is rotated, okay, so this is the applied moment, right? So the head of the arrow will be compression, and the tail end of the arrow will be in tensile. Okay, so we got this right already. Okay, we got this right. So now, right, I'm going to label the points. Okay, so I'm going to call the top like before alpha, over here beta, and this is I, and over here is J. Okay, right? We have this already. Okay, now before I go on, some of you might be confused why the vector arrow is like this. Okay, why the vector arrow is like so. I'm going to teach you a simple way to remember. Okay, simple way to remember. Look, I like to make things simple for you to remember so that when you do your future courses, you can recall easily. Okay. I don't want you all to like, oh, read the textbook. Have you all tried reading the textbook in B and Johnson? Up to today, sometimes when I read it, I don't understand what they're saying. I will tell you that. Okay. So now let me help you how to. So the moment vector, regarding the moment vector now, okay. What I tend to do, or when I think you guys are very strong in vectors, okay. So I do teach in another department where students are not that strong in their vectors. So this is what I teach them. Okay. So what I tend to do is I would just draw a arrow. You just need to know one direction. Okay. And this is the rotation based on right hand rule. So I will call this compression, and I'll call this tensile. Okay, I'll call this compression, and I'll call that tensile. Okay, so all I do is I just take this. Okay, I just copy, and I'll just paste. Okay, and I will then where is the rotate? Okay, so rotate right. Okay. So if the moment vector is pointing towards the right, okay, that is your tensile and compression. Okay, and then if it's rotate, if it's downwards, okay, I rotate again. Okay, rotate right. That is where your tensile and compression is. Okay, or in your test, you just rotate your paper. Okay, and then one more time. Okay, so some of you, if you are confused regarding the moment vector, okay, which is tensile, which is compression, okay, there you go. Okay, so let's use this. Okay, so the my is easy. The mz is going that direction. There's a rotation. You just move this arrow here. See, it's exactly the same. Okay, so you can use this method. Okay, try to reduce your mistake, especially when you have a 3D structure. I find this really useful. Now, coming back to my point now. Okay, so now we are going to have we are going to find stress x at point alpha, stress x at point beta, stress X at point I, and stress X. I need another layer. Okay. Stress X at point J. Okay. So let's look at the moment. Okay, let's look at it. So the moment that we're going to look at is my. Okay, so my I'm going to write in pink. Okay, so I want you to focus on the pink vector. Okay, so at point alpha, moment about y. Okay, so we're looking at alpha now. Okay, the moment induced by y will induce a tensor which is positive. Okay, at point B, the moment y will induce a what? So this is our point B now. Will induce a compression. Okay, and then if you look at I, okay, if you look at point I now, my will induce a tensor. And if you look at moment about y-axis and look at point J, it will induce a compression. Okay, are you all clear? Okay, it's not so you can determine whether is it tensile or compression very easily. Okay, then the next thing is any question? I will show it again. Okay, in terms of mz, and you can do it yourself. Okay, so if we look at mz, okay, if you look at mz alpha, so mz you have to focus on the moment about z. Okay, so we have to focus about mz now. Okay, the orange line now. Okay, so mz you can see on alpha, right? Mz is going to be in compression. Okay, and at beta, mz is also going to be compression. Okay, then at point I, where I'm circling the I now, mz is in tensile, and J, right? Mz is in tensile. Right? So what you see from here is stress X beta will have the maximum compression. Okay, and stress X at point J will have the maximum tensor. And what we realize is stress X alpha is not equal to stress X beta. Okay, and stress in the X direction of point I is not equal to stress X direction at point J. This is what we classify as unsymmetrical bending. Okay, it's important that you all see this now. Okay, you can see the difference. Yes or no? Shouldn't point I be the point I? Oh yeah, you are right. You're right. I got it wrong. You're right. Emerson, Android. Okay, when I see you, I buy you a good beer. Thank you. I make sure it's a good one. I don't buy cheap beer, okay? Any mistake you found me doing, you get a pint, okay? Okay? So this is where we get unsymmetrical bending. Okay? Are we clear? Okay. Now, I want to elaborate where mistake are made, and I want you all to prevent making this mistake. So let's go back to the formula again. Let's go back to the formula again. Okay. So I'm going to go into this formula over here, and I'm going to paste over here. Okay. So my and mz is usually not a problem. Okay. But what I realize is up to today, even gadget engineers that have graduated have this problem to identify how to calculate Iyy and Izz. If it's just one direction, it's fine. Okay. Whereas both direction can be a bit confusing. Okay. So so I'm going to teach you a way that's easy to calculate and easy to remember, and it will help all of you in your quiz. Okay. It will help all of you in your quiz. So let's say now, okay, we have again the same geometry, and I'm going to sketch the same transformation. So this is y, this is z, rotation in the x. Okay. And to find I, the general formula to find I, okay, general formula, I is in terms of English, okay, is width multiplied by depth cube divided by 12. Okay, that is in English. Okay, in English is width multiplied by depth cube divided by 12. Okay, that's what I was taught. So if the structure is oriented, what you see, the horizontal thing will be width, the deeper end will be its depth. Okay, why? If I was a human being, I put myself there. The depth is my height, and the width is left to right. Okay, that's what I was. I did my degree in England. Okay, in Birmingham. I did not know this. Okay, so when is it a width and when is it a depth? Okay, it goes like that, dependent on the axis of interest. Okay, so this is the answer. Okay, I'll be quick. I know I'm running out of time. Okay, so now if the interest, the axis of interest, okay, the axis of interest now is your ZZ. Okay, it's your ZZ. So I'm going to come back to here, right? So this is my A, and this over here is our B. Okay. So any geometry, so if your interest is ZZ, any geometry that is parallel to the ZZ axis is known as the width. Any geometry that is perpendicular, okay, that is perpendicular, okay, is your depth. Okay. So for this case, the IZZ is equal to the width is A B cubed over 12. Okay. A lot of times we don't have problem with this. Now, if our interest is Iyy, if our interest is Iyy now, so I'm going to draw our y axis. Okay. So this is your y. So any geometry that is parallel to the axis of interest, now this become your width. And over here now, which is 90 degrees to axis, this is become your what? Your depth. So therefore, Iyy is equal, so your width is B, your depth is A cubed over 12. Okay, so this is how you should identify whether it's IYY or IZZ. So in summary, I'm going to summarize and I'm done. Okay, I know I'm near the end. So the summary is what? Geometry, parallel to axis of interest is the width. Okay, geometry perpendicular to axis of interest is the depth. Okay, so this is how I think, okay, that I think that so that I will not make mistake. If I don't follow these rules, okay, I tend to make this sort of mistake. Doesn't mean there are two depths. Depend on your axis travel. Okay, depend on the axis that you are looking at. Okay, before I stop, I would like to. I did not mention this in earlier on Friday. Okay, I'm going to lecture from 8:30 to 9:20, 10:30 to 11:20 because of snow day. I want to make things up. Okay, I don't want to be too behind schedule. If that's the case, go for your next class. I'll see you guys on Friday. Go. Bye. I'll still be around if you have question. Okay.